Today's lesson is section 5-3, and we're basically going to concentrate on solving polynomial equations, finding out where the graph of these polynomials cross the x-axis. Sometimes the solution will be imaginary, and so therefore the graph will not cross the x-axis. So, a couple things that we want to focus on. So here are our procedures for solving polynomial equations. First and foremost, we want to write the equation so that it's set equal to 0. Then you're going to factor. So today our equations are for the most part factorable. There are some parts that are not. We'll talk about what to do in that case. And then this third thing you're going to do is once it's factored and set equal to 0, you're going to use the zero product property. And so that's just a fancy way of saying set each factor equal to 0 and solve. So that's all that means. So we're going to go through and just quickly review your factoring formulas and methods, and then I'm going to let you do a bunch of factoring, and then you're going to check your work. So let's just start there. So our first one that we're going to look at are the sum of cubes, and so your factor pattern would be some cube plus another cube. And if you have that, then the factor pattern, if you recall, would be a plus b times a squared minus ab plus b squared. So remember that the pattern would be take the cube root of each of these and it goes here a and b. And then forget about this. You're going to focus solely on the binomial. To get this trinomial, you'll take this and square them. They become your bookends. And then to get the middle term, you're going to just multiply the a and b together and you get a and b. As far as your signs go, remember that these are the same, these are opposite, and this is always positive. So then we can do the same thing in this case. So to get the binomial, I'm going to take a minus b. So I'm taking the cube root of a cubed and b cubed. To get my trinomial, my bookends, I'm going to take a and square it, b and square it, and then my middle term is ab because I'm multiplying the a and b together. So for my signs, remember the reason why I put a negative here is because these are same signs. These are going to be opposite. So I'm going to have a plus here, and this is always positive. So I have a plus here. So you go ahead and pause the video. I want you to factor x cubed plus 8 and x cubed minus 27, then restart the video. Okay, so your factoring here would be x plus 2 and then x squared minus 2x plus 4. This trinomial will never be factorable. And then on x cubed minus 27, you will have x minus 3, then x squared plus 3x plus 9. All right, so here you're going to review all of your different techniques of factoring. So if I would prefer that you try to pause the video and perform this factoring on your own. The only one you might have trouble with is the difference of two squares one, but when you look at my work, it'll make a little bit more sense. It's on a little bit more advanced level. But go ahead and pause the video and then restart it once you get to example 1. Don't do example 1, but restart the video before that. Okay, so for factoring out the GCF, all three of these have a 9 and an x squared in common. And so that 9x squared gets pulled out in front. And then 18 divided by 9 is 2. X squared, or x to the 4th divided by x squared is x squared. Then negative 27 divided by 9 is negative 3. X cubed divided by x squared is x. 45 divided by 9 is positive 5. And the x squareds are going to cancel. So this becomes your factored answer. Then for the trinomials, so in this particular one, fact, I'm going to make this bigger. So for this particular one, you've got a coefficient in front of the squared term. So we're going to have to swing multiply that to the -4. So it creates a new trinomial, x squared minus 5x minus 24. And then we're going to find the factors of 24 that subtract to give us -5. So in my t-chart, my 24 is negative. That causes me to subtract, and I'm looking for my middle term of -5. So the factors of 24, 3 and 8, that subtract to give you 5, are 3 and 8. My 5 is negative, so the bigger of the two carries that same sign. The 3 is going to have to be positive to combine with the 8 to make it negative. So you end up with x plus 3 and x minus 8. And then because we multiply by the 6 at the very beginning, we're going to have to divide each of these by 6. Since 6 does not divide evenly into 3 or 8, remember you have to reduce this fraction and reduce this fraction before you can pop up this denominator in front of the x. So for 3/6, they're both divisible by 3, so I get a +1 and a 2. And on 8/6, they're both divisible by 2, so I get a -4 and a +3. So then when I finally pop up, I get a 2x plus 1 and a 3x minus 4. And there's my final answer. All right, then for perfect square trinomials, remember these are your factor patterns, and so you want to test them to make sure that the middle term matches the 2ab. So that's what you'll see me doing. And so here, I'm going to make them bigger. So my test is 2 times a times b So remember, to get my a and b, I'm taking the square root. Oops, let me move my stuff over. Okay, so I'm going to take the square root of x squared, I get x, and the square root of 64, I get 8. If I multiply 2 times x times 8, I get a 16x, and that matches right there. So because it matches, I know that it factors into this parentheses squared. Remember, each one of these contributes something to the factoring here. So I'm going to take my square root of x squared here, which is x, and then my middle sign here goes here, so that's a plus. And then the square root of 64 goes here, which is 8. And so remember, you already did this work here and here, so you just have to bring it down and bring down the sign of that middle term. So this becomes your final factoring. Then over here, if I test it with 2ab, and I take the square root of my bookends, I get x and 8, and again that is 16x. We don't care about the sign, it still matches. Alright, so this is going to factor as the x is going to go here and the 8 here, and the sign of the middle term is negative. Then let's look at the difference of two squares. So for the difference of two squares, if you have the difference of two perfect squares, you're going to get this plus minus pattern. And you're going to take the square root of each of those, and they're going to go here. Well, this one we wouldn't ordinarily view as the difference of two squares. We have a perfect square and a perfect square, but 3 is not a perfect square. However, we can still force it to work, and I can just use the same process. So for instance, if I force it to follow the pattern of the difference of two squares, I would have a plus minus pattern. Then to get my a, I'm going to take, whoops, I wanted that to be red. I'm going to take the square root of 4x squared. Well, the 2x goes here and here. And then to get my second term, I'm going to take the square root of 3. Since I cannot take the square root of 3, you're going to put the square root of 3 here and here. So even though this was not a perfect square, I can force it and use the pattern because I have a different sign here and just put the square root of 3 here. Radical 3 times negative radical 3 is still going to give you a negative 3. So it is still going to work. So that's kind of a new one on you. Then, factor by grouping. This is where you're going to cut your group in half and take the GCF. So over here, I'm going to cut this group in half. The first group has a GCF of x squared. So then pull that out in front. And then when you divide, you get x minus 4 left over. The second group, I have a GCF of 9, but because that third term is negative, I want to factor out a negative 9. If I don't factor out the negative 9, this first term that's going to go here will not end up being positive, and it won't match the other first term. So the negative 9s cancel, and you're left with a positive x. Positive 36 divided by negative 9 is negative 4. And so now they have these two in common. So you're going to bring in x minus 4 out in front of parentheses. So these got pulled out in front. And what's left over, the x squared minus 9, right here, they're going to get dropped in to that empty parentheses behind. However, we can't factor this, but we can factor this. This is that difference of two perfect squares again. So I'm going to bring the x minus 4 down, exactly as you see. But this binomial factors into a plus minus pattern. So the square root of x squared is x, and the square root of 9 is 3. So then this ends up being, whoops, my final answer here. Then we have the sum and difference of two cubes. So 64 is a perfect cube, it's 4 cubed. Perfect cube, 1 is always a perfect cube. So I'm going to follow that pattern. Here's my binomial. I'm going to take the cube root of this. I get 4x. And I'm going to take the cube root of 1, and I get 1. Then for my binomial, I'm going to square this and square this. So I get 16x squared and a 1. And to get my middle term here, I'm just multiplying those two together, and that gives me a 4x. Then for your signs, remember here I'm going to have same sign, so I have a plus. And then these are opposite signs, so I have a minus, and then this one is always positive. And there you have that. And then the final one, here I have the difference of two perfect squares. So I'm going to have the same binomial as above, but my signs are going to change. So again, I want to do same sign here. So I've got a minus, and then opposite signs here. So I have a plus, and of course this is always positive. And that is a total review of all of your possible factoring. All right, so let's focus, whoops, I did not mean to do that. Let's focus on solutions by factoring. So in example 1a, this has already been factored for the most part for you. This is the sum of two squares, and you cannot factor that. But this is still the difference of two squares. And I always want you to focus on what is my leading term, what's my highest degree term. Now, because this is already factored, it's hard to see it. But if I multiply these two together here, I would have an x to the 4th. That's going to give me my highest degree term. And remember, whatever your highest degree is, that means that you should have, in this case, 4 solutions. So 4 solutions. Your solutions can be imaginary, they can be real, so bear that in mind. But do know that if you have an imaginary solution, they will always come in pairs. Imaginary solutions do not cause the graph to cross the x-axis. Only the real solutions will cause your graph to cross the x-axis. So, because this can still be factored further, that's what I'm going to do. So I'm going to factor this into its plus minus pattern. So the square root of x squared is x, and the square root of 1 is 1. And then I'm going to continue and bring down the x squared plus 4, and all of this is equal to 0. So then you're going to set each one of these factors equal to 0. And solve. So here, if I subtract 1, I'm going to get x equals -1, so there's one solution. Here I'm going to add 1, and so I get x equals 1. Here I'm going to subtract 4, and I get x squared is equal to -4. And in order to solve for x, I'm going to take the square root of both sides, but I have to do plus or minus the square root on the right side. So the square root of x squared is x, plus or minus. Remember that this negative is going to come out in front as an I, and then the square root of 4 is 2. So this gives me a total of 1, 2, 3, and 4 solutions. So I have my total of 4 solutions. These two are imaginary. They will not cross the x-axis. These two, they each have a multiplicity of 1, meaning there's only one of these and one of these. So they will these will cause the graph to cross the x-axis at -1 and +1. All right, so let's look at B. So for B, we need to have one side set equal to 0. This is my highest degree term out of all of these, and it's currently positive. So I want all of these to be moved to the left side. So we're going to move them algebraically. So I really don't have anything to line that up to, and I don't have a lot of room to put it off to itself. So even though I know that it doesn't match up with x to the 5th, I'm going to put it underneath that one. And so these are going to cancel over here. And I'm going to write my terms in descending order. So x to the 5th minus the 5x to the 4th. And then these are going to combine to give me 6x cubed. And it's equal to 0. So now use your factoring techniques. All three of these have an x in common, and at most there are 3 x's in common. So I'm going to divide by x cubed and pull an x cubed out in front. So x to the 5th divided by x cubed is x squared minus 5. X to the 4th divided by x cubed is just x. And then these are going to cancel, and we have plus 6. So then look at this trinomial here. What factors of 6 add to give you 5? So in my chart, my 6 is positive, so that causes me to add the factors of 6, and I'm looking for a 5. The only factors of 6 that add, because 1 and 6 subtract to give you 5, but we want them to be added so that we get a positive 6. So we cannot choose 1 and 6. But 2 and 3 do indeed add to give you 5. So this is the one we're choosing. And the 5 is negative, so the bigger of the two carries that sign. And the 2 will also have to be negative. So then the x cubed gets brought down, and then the trinomial gets split into x minus 2 and x minus 3 equals 0. So then set each of your factors equal to 0. And then solve. Well, technically, if x cubed is equal to 0, then x is equal to 0. On the second one, x is going to equal 2 if you add 2 to both sides. And on the third one, x will equal 3. Now, because my highest degree term was 5, the degree of the polynomial is equal to 5. So that means I should have 5 solutions, but I only see 3. That's because this one, x equals 0, has a multiplicity of 3. Meaning there are 3 x equals 0s. And so since the multiplicity of 3, from what we talked about in one of our previous lessons the other day, is it will act like, since this is an odd number, it will be crossing the x-axis. So I expect at 0 that my graph will actually cross the x-axis there. Then for x equals 2, this has a multiplicity of 1, and again that's an odd number, so it's going to cross the x-axis. And then this has a multiplicity of 1, and so it will cross the x-axis at 1. And then if you look at these, so I have a multiplicity of 3, then that'll be my 4th one, and my 5th one, there's my 5 solutions. All right, so let's move on to example 2. So we're still going to solve by factoring, but this time we can have real or imaginary solutions. So here, we need to move the 16 over to its highest degree term. So we're going to subtract 16. So I end up with x to the 4th minus 16 is equal to 0. And then remember, this is the difference of two perfect squares. So it is going to factor into this plus minus pattern. And so the square root of x to the 4th is x squared. And the square root of 16 is 4. I cannot factor the sum of two squares, but this is certainly factorable. So I'm going to bring down the x squared plus 4. I can't do anything with that. But then the x squared minus 4 is the difference of two squares. So it is going to factor into, this right here is going to factor into that plus minus pattern. So I'll take the square root of x squared, which is x, and the square root of 4, which is 2. So then I'm going to set x squared plus 4 equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. For the first one, if I subtract 4, I get x squared equals negative 4. And when I take the square root, remember I have to do plus or minus the square root, I get x is equal to positive or negative 2i because of the square root of a negative number. Then for the second one, I get x equals negative 2. And for the third one, x equals 2. So these are my solution. So it looks like I only have 3 solutions, but I really have 2 here, 1 here, and 1 here. So that's 4 total. This is a degree of 4, so I found all 4 solutions. These 2 solutions are imaginary. So the graph of x to the 4th minus 16 is not going to cross the x-axis except for in these 2 places. So it will only cross the x-axis in 2 places. For B, again, I want to move everything to the left. So I'm going to add their opposites. Okay, so if I add and subtract, I'm going to get x cubed. I'm going to put them in descending order, so I'm going to add a 2x squared. And I'm going to subtract an 8x from both sides. And that will give me 0 on the right. Then using my factoring skills, I notice I have a GCF of x, so that gets brought out in front. And I'm left with x squared plus 2x minus 8. So then you want to ask yourself, what factors of 8 subtract to give me 2? Well, that would be 2 and 4. So what factors of 8? My 8 is negative, so that's why I'm subtracting to get my middle term of positive 2. So 2 times 4 is 8. They subtract to give me 2. My 2 is positive, so the 4, being bigger, automatically gets that sign. The 2 is going to have to be negative. So then I end up with x times x minus 2 and x plus 4 equals 0. Set each of your factors equal to 0. and then this is already solved. If I add 2 to both sides on this one, I get x equals 2, and subtract 4 to both sides, I get x equals negative 4. And I'm checking to see, do I have all solutions? So my highest degree term here or here is x cubed, meaning I should have 3 solutions. And here I have 1, 2, 3. They each have a multiplicity of 1, so my graph is going to cross the x-axis at 0, 2, and negative 4. Let's look at C. So for C, it looks a little bit more complex, but really all you need to do is distribute the x into the parentheses and the 8 into the parentheses to break up those parentheses. So I would end up with x cubed plus 8x is equal to 8x plus 8. And so then we have a problem that's very similar to example 1, part B. And so I want to move everything to where my highest degree term is. So I'm going to subtract an 8x, and I'm going to subtract an 8 from both sides. So I end up with x cubed. These are going to cancel, and then minus 8 equals 0. I have a perfect cube minus, this is a perfect cube because 2 cubed is 8. So I'm going to use my difference of 2 cubes, where I have a binomial and a trinomial. And so the cube root here and here would be x and 2. To get my bookends, I'm going to square the x and square the 2. To get my middle term, I'm going to multiply the x and the 2, and so I get 2x. My signs, remember, same sign, opposite sign, always positive. So I can actually set x minus 2 equal to 0 and x squared plus 2x plus 4 also equal to 0. Because remember, this cannot be factored. We'll talk about what to do with this in a minute. But this right here is going to give me one of my solutions if I add 2 to both sides. Because when I'm distributed, and I look at these terms here, this is my highest degree term, which is 3. So I should have 3 solutions. So this is one of them. I'm going to have to get my other solutions from this one. Since it's not factorable, I'm actually going to have to use the quadratic formula. So that's going to require me to find a, b, and c. So a is the coefficient of the squared term, which is 1. B is the coefficient of the x term, which is 2. And c is my constant. So I'm going to move this over, and I'm going to use a, b, and c and the quadratic formula. So remember, your quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to write my template. So I'm going to remove all the variables and just put substitution parentheses in place. So then a is 1, or I'm going to start with b. So b is 2 and 2, and then a is 1 and 1, and c is 4. So I get the opposite of 2, plus or minus the square root of 4 minus 16, which is negative 12, over 2. So I get negative 2 plus or minus the square root of negative 12 simplifies to 2i square root of 3 all over 2. Then you have to divide each of those by 2, so you get negative 1 plus or minus I square root of 3. And so that's what x equals. So this is your 2 other answers. And so I had one answer already, and that was this one right here. And then these are going to be 2 imaginary numbers, so it gives me my total of 3 altogether. These will not cause the graph to cross the x-axis. This will cause the graph to cross the x-axis at 2. All right, so then let's look at example 3, which is finding real roots by graphing. So if you look at, there's 2 different methods you can use. Method 1 is the intersect feature on your calculator, and method 2 is using the 0 feature. I prefer the 0 feature, but if you want to use the intersect feature, so if you have this particular problem here, x cubed plus x squared equals x minus 1. You can take and put into your y equals on your calculator. You can put this into one y equals and this into a second y equals on your y equals menu. Then hit graph. When you look at your graph, you're going to have this right here for this graph and this line right here for this graph. And then you're going to use second calc. So you'll do second calc, which is the trace key, and then you'll choose intersect. And so then it'll put your cursor like right here on one of the lines, and then it'll say first line, and you'll hit enter. You want it to be somewhere around this intersection here because this is the only place where these two graphs intersect. And then it'll say second line, and it'll move this to maybe the second line over here, and you'll say yes, and then it'll say guess, and you'll hit enter, and it'll put the cursor right here. So when it does that, it should give you the following value. You can kind of check to see if you did it right. Actually, I'm going to get a different color here. So right here, this is the intersection, and this value on your calculator should come out to be, if you follow those directions, so all I care about is where it would be hitting the x-axis, because remember, this isn't really the true graph of what this is. I'm going to show you method 2 here in a minute that will give you a clearer picture. But all I care about is the x value. So the y value for using the intersect purposes means nothing. So this is your real answer. Because our highest degree term here is the x cubed, I should have 3 answers. Well, there's only one intersection to these two graphs, so that means I have one real answer and 2 imaginary answers. So my one real answer is x equals negative 1.839. So let's look at method 2. Method 2 is your 0 feature on the calculator. This is the feature that I prefer. So what you're going to do is you're going to take that same equation, I'm going to write it up here, you're going to do what we did all along when we were factoring. You're going to move all of this over to the left to be with the highest degree term. So what you're going to put into your y equals is, whoops, that clearly is not what I wanted to have. You're going to put x cubed plus x squared. You're going to subtract the x and add the 1. And that typically we would let equal 0. And then we'd have to try to factor and go from there. But if you're going to put it in the calculator, you put all of this into y sub 1 and hit graph. And then you will come out with this graph right here. And so what we want to do is find the actual 0, which is where it crosses the x-axis. So you're still going to go to the second calc menu. But instead of choosing intersect this time, because I don't have another line that it's intersecting with, I'm trying to find the root, or what's called the 0. That's what you want to choose, is 0. So then it's going to say left bound, and so you'll want to make sure that your cursor is somewhere down here because that's the left of the 0, and then hit enter, and then it'll say right bound, so you'll move the cursor up to the right of the 0, which means it'll be up here, and hit enter, and then it'll say guess, and it's going to give you the following result. So this right here will show you as negative 1.839 comma 0. And that's really your true answer. So notice that this x value corresponds to the x value for method 1. I prefer to use the 0 feature, but you can use whichever one you like. All right, let's finish off by doing 2 word problems. So we've done consecutive integer problems before, and so you want to be highlighting and underlining things that are important. So we have 3 consecutive integers. That's not what I wanted to do. I'm trying to highlight. Let's try that again. 3 consecutive integers. And we'll talk about more here in a minute, but 3 consecutive integers. So remember that they have a very specific setup. So I'm going to let my first equal something, my second equal something, and my third equal something. So consecutive integers, if you'll recall, are numbers that are one right after the other, like 1, 2, 3, 5, 6, 7. They can be positive, negative, they can include 0, but they have to be integers, no fractions or decimals. And so we typically, and they always have a distance of 1 between each number. And so we will typically let the first be x. The second one's going to be 1 more than the first, and the third is going to be 2 more than the first. So 3 consecutive integers setup is going to be x, x plus 1, x plus 2. Now if this said 3 consecutive even integers, even numbers like 2, 4, 6, 8, they have a distance of 2 in between them. So instead of x, x plus 1, x plus 2, you'd have x, x plus 2, x plus 4. If this said 3 consecutive odd integers, this setup is not plus 1 plus 3. Odd integers have the same setup as even integers because odd integers also have a distance of 2 in between them. So if you had even or odd integers, you would have x, x plus 2, x plus 4. So don't get caught up in that. All right, so 3 consecutive integers whose product is. So their product, so we're going to multiply those together. Whose product is. Is another word for equals. So here's where my equals goes. I'm going to move this over a little bit. So then it's 480 more than, so that would be 480 plus their sum. So their sum is an important amount, and that would look like, if I add all 3 of these together, I'm going to get 3x's plus 3. So 3x's plus 3. So how do you solve this? Well, since this is such a large number, I'm not going to expect you to do this one by hand, so let's get it ready for the calculator. You could multiply this all out, but it's not necessary. Let's go ahead and collect like terms here first. So I have x times x plus 1 times x plus 2 equals 483 plus 3x. So then I want to move the 43 and the 3x to the left by subtracting them, because I want one side to be 0. Then I'm going to subtract the 3x and subtract the 483, and now I have one side equal to 0. What I want you to do is you're going to put all of this into y equals in your calculator. So you go ahead and put this into y equals in your calculator. And then you're going to hit graph. And when you hit graph, because the 43 is going to be a bit of a problem, you're going to see a graph that kind of looks like this. Even if you zoom out, you still can't capture all of it. And really what that means is, if I were to actually multiply with this times this times this, I'd get an x cubed. So I'm looking for 3 solutions or 3 possibilities where it might cross the x-axis. But because this is all you can see in your window, my assumption is that it's crossing the x-axis here, and it has 2 imaginary solutions, because remember, the imaginary solutions come in pairs. So go and hit your second calc on your calculator and find the 0 command and find the value of this. It appears that it's near the number 7, which in fact, if you do second calc 0 and do left bound and right bound, you do come out with x equaling 7. And so that means that x plus 1 is going to be 8 and x plus 2 is going to be 9. So therefore, the consecutive integers are 7, 8, and 9. All right, so let's do the last problem. And so on the last problem, we have the Perez twins. And it says the Perez twins were born 2 years after their older sister. This year, the product of the three siblings' ages is exactly 4,558 more than the sum of their ages. How old are the twins? Well, they're defining for you the Perez twins were born 2 years after their older sister. So in this case here, who do we know nothing about? They're describing the Perez twins. I know nothing about the older sister. So typically, whomever I know nothing about, that's going to be my single x. So I'm going to let the older sibling equal x. And then the twins, if they were born 2 years after, that means they're 2 years younger. So the twins are going to equal their older sibling minus 2 years, because they're 2 years behind. Then to set up our equation to solve, continue reading. This year, the product of the three, emphasis on 3 and product, ages is exactly. So I have to find their products. So the older sibling is x. One of the twins is x minus 2, but don't forget you have to account for all 3 children. So you have to take x minus 2 times itself twice, because this is the older sibling and each of the twins you have to multiply their ages. And I'm going to move this over a little bit. So the product of the three siblings' ages is, remember is means equals, 4,558 more than, which is a plus, the sum of their ages. So if I add these together, remember I have another x plus 2 to count for. So I've got 3 x's and 2 negative 2. So that's 3 x's minus 4. 3x minus 4. So let's collect like terms. X times x minus 2 times x minus 2 equals 4,554 plus 3x. Then move everything over to the left to set one side equal to 0. All right, so then what I want you to do is go ahead and put this into the y equals, pause the video, and see if you can determine what the solution is. All right, so if you pause the video and you plug this in, you should see an answer or a graph that looks something like this. So it only crosses the x-axis in one place, and if you do second calc 0, you will get an answer here of 16, 0. So that means that x is equal to 16, so x minus 2 is equal to, backtrack that. You will not, it's going to look like this. This is not going to be at 16, this is going to be at 18. My bad. So this is at 18, and so then the twins are going to be at 16. And the question says, how old are the twins? So if you had just answered the 18, we really want the twins, and that's minus 2. So therefore, the twins are 16 years old. All right, good luck with your homework. Ask me whatever questions you have.